Good morning. Today we are going to see pressure measurement. What is meant by pressure? Pressure is nothing but force by area. We have different types of pressure: low pressure, high pressure and medium pressure. Low pressure can be measured in terms of tar, bar, mm of Hg, mm of water column. High and low medium pressure can be measured in terms of Pascal, PSI, Newton per meter square. So in this pressure measurement, pressure gauge is used to measure the different kinds of pressure. So we have different types of pressure measuring instruments: elastic type pressure measuring instrument, and in this elastic type we have three different types: diaphragm, bellows, and Bourdon gauge is used to measure the pressure in terms of elastic type. So pressure gauge is used to measure the pressure, that to gauge pressure. So gauge pressure is equal to absolute pressure minus atmospheric pressure. Today we are going to see Bourdon tube. What is meant by Bourdon gauge? Bourdon gauge is used to measure the medium pressure to high pressure, and also it is the type of elastic. If we give any pressure to this Bourdon gauge, which will deflect, which will produce displacement. That deflection is directly proportional to applied pressure. This is the basic principle behind Bourdon tube. It is used to measure the medium pressure to high pressure, that to 600 millibar to 4000 bar. We have different types of Bourdon tube: C-shaped Bourdon tube, spiral type Bourdon tube, helical type Bourdon tube. So based on the construction, we are classified into three different types. So basic principle of this Bourdon tube: if it is a kind of elastic transducer, if we apply pressure to this elastic member, which will deflect, the deflection is directly proportional to applied pressure. So here the construction view of C-type Bourdon tube. In this C-type Bourdon tube, we have C-shaped Bourdon tube. One end is fixed end, another end is free end. In this fixed end, we have to give the pressure to be measured. At the free end, we will get the deflection, that is displacement. So, and also the free end is connected to the mechanical linkage, so that we can transfer the displacement produced by the free end to the spring arrangement. In the spring arrangement, we have to connect with the pointer and scale arrangement, so that it will indicate the final reading. So this is a construction view of C-type Bourdon tube. The working principle of C-type Bourdon tube: when the unknown pressure is applied to the Bourdon tube at the fixed end, the pressure is first converted into force. So throughout the pipeline and Bourdon tube, the pressure is converted into force. At the free end, the force is converted into displacement. This Bourdon tube is also called as primary transducer. So what is meant by primary transducer? Primary transducer which converts one form of physical quantity into another form of physical quantity, that is pressure into displacement. So pressure is one form of physical quantity and displacement is another form of physical quantity. At the free end, we will get the displacement. That displacement is given to the mechanical linkage. So based on the displacement, the mechanical linkage will transfer the displacement into spring arrangement. Here we are having spring arrangement. That spring arrangement is used to amplify the small amount of displacement into large amount of displacement. That amplified displacement is given to the pointer and scale arrangement, so that the pointer will indicate the corresponding pressure. The scale is calibrated in terms of pressure. So it is used to measure the medium to high pressure. So the scale is calibrated in terms of Pascal or PSI. So this is the working principle of Bourdon tube. So we have C-shaped Bourdon tube. So we have two different ends one end is fixed end, other end is free end. In the fixed end we have to give the input unknown pressure. At the free end we will get the displacement. This mechanical linkage will transfer the displacement from free end to spring. So spring is used to amplify the small amount of displacement into large amount of displacement. That displacement is given to the pointer and scale arrangement. So pointer will indicate the corresponding pressure. So advantages of Bourdon tube. So advantages of Bourdon tube. Bourdon tube low cost and also simple in construction. They can modify to give electrical outputs. So if you want to convert this displacement into electrical signal, means we have to use secondary transducer so that we can convert pressure into electrical signal. They are safe even for high pressure measurement, and also accuracy is high, especially at high pressure. Limitations of Bourdon tube: they respond slowly to change in pressure. That is the main disadvantages. And also they are subjected to hysteresis error. They are sensitive to shock and vibration. If any shock or vibration produced, means the output will affect. And also we need amplification. So amplification is must, as the displacement of the free end of the Bourdon tube is low. So always the Bourdon tube free end will produce less amount of displacement, so we need amplification. So for that only we are using spring. It cannot be used for precise measurement. So that is the disadvantages of Bourdon tube. Thank you.